Alright, so welcome to day 2. Just making sure that's recording. Yep. So for day 2 of geometry, we're going to be talking about circles and line segments. So we're talking about the vocabulary for circles and line segments. So we're still dealing with a lot of vocabulary words, so you're going to have to unfortunately deal with me reading a lot of the things that are up on the screen. So we're going to talk about circles, a two-dimensional shape made up of points, all having the same distance from a given point, called the center of the circle. A subtended angle is an angle formed by an arc or a line at a given point. And a line segment is a portion of a line between two endpoints. Line segment AB, written as AB, is shown below. So the difference between what we learned yesterday, or for day 1, a line AB would have had the little arrows at the end. A ray had one arrow at the end, and a line segment has no arrows at the end, and it ends with two endpoints. So some of you guys were asking about a line segment in your homework from yesterday. So if you did day 1 homework, you would have noticed that there were line segments that you weren't having to write it down because they were segments and not rays or lines. So again, line segments have two endpoints, and when you're writing out the abbreviation for it, it's just a solid line with no arrows or dots at the end. The center of a circle is a fixed point inside a circle that is the same distance from every point on the circle. Circles are named based on their center. In circle O, the center is shown. So O would be our center. The box actually isn't supposed to be there. I don't know why it's there. I probably should have fixed that, but it's there. So this circle is named O. That's like the letter O, not a circle, not a zero. So again, to name this circle, you would name it after whatever you put here in the middle of the center of the circle. So for example, 1, draw and label GH. So the solution should kind of look like that. So GH should have a line with two endpoints. G should be on the left, H should end it. That's the reason why it's in that order. If it was the other order, H would have been on the left and G would have been on the right. So line segment GH is written like this. So there are going to be a couple of examples in this video where you can kind of pause it and try it on your own, or you can keep going and wait till you do your homework in order to practice. So in example 2, from the figure below, list all the line segments. So again, line segments are two endpoints. So you can pause the video and try and see if you can figure it out on your own, or you can continue on with the video. I'm going to pause for a second to give you guys a choice, and then I'm going to give you all the answers. Alright, hopefully you did pause. If not, then this is the answer. So there are actually quite a few line segments. So again, remember, a line segment is two endpoints. So we can go in any direction. You don't have to start off with A, but I'm going to start off with A. So from A, B would be a line segment. BC would be another line segment. AC would be a line segment. BE would be one. BF would be one. And BD would be one. If we did B's as our like middle point and went that way. The answers on the other slide are going to be a little bit different because they started off with the left and went in. But for the most part, everything that I had just mentioned are right here on this slide. So DE, DB, BE, FB, AB, BC, and AC. So again, it's a line segment. We know that because the line on the top does not have any arrows. Alright, so let's talk about parts of the circle. We have the radius. The radius is the distance from the center of a circle to any point on the circle. So we have the center here. We know it's a center because, well, it looks like it's a center. My O, which is the name of the circle, is there too. So whenever you name your circle, your letter should be right next to your this middle dot. And then the distance between this center to the edge of your circle is called a radius. A chord is a straight line that joins any 2 points on the circle, or simply a line segment whose endpoints lie on the circle. So it can be anywhere. It can be here to here, so PQ, RS. I can have it all the way down this way. I can barely cover it and go straight across. So like if I actually drew an arrow or a line, if I could draw it straight, that could be a chord. 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 It doesn't matter. It could be something itty bitty tiny. And that is still considered a chord because it's 1 point here to 1 point there. So a diameter is a little bit different than a chord. A diameter would be from the center all the way across. So it has to, so a line segment which goes through the center of the circle and whose both endpoints lie on the circle, or simply a chord which passes through the center of the chord. The diameter is the longest chord in a circle. So it can be right here down the middle this way. It can be going this way. It can be going this way. So think of a pizza pie. So it has to be a line that would go for a pizza pie. Oops. A circumference is a distance around the edge of a circle, or simply the perimeter of a circle. So it would be going all the way around our circle. An arc, on the other hand, is part of the circumference of a circle. An arc is named according to its endpoints. So AB is an arc. So if I'm talking about AB and going in between this part, this would be the minor arc. If I went A and went all the way around to B, that would be a major arc. All right? So minor arc is a little smaller part. Major arc would be all the way around. A semicircle is half a circle formed when we cut a circle along its diameter. So semicircle is half of a circle. A minor arc would be less than half of the circle. A major arc would be more than half of the circle. That's the easiest way of figuring it out, of understanding that. So semicircle is half. Minor is less than half. Major is more than half. In the figure below, AB is the minor arc, and oh, I forgot my C. But ABC would be all the way around. So a segment is the region of a circle bounded by a chord and an arc. A chord divides a circle into 2 parts called segments. A major segment is the region bounded by the chord and the major arc. The minor segment is the region bounded by the chord and the minor arc. So in a second, I will show you an example of that. So here I have my circle. Here's my chord, 1 point to the other. The minor segment would be the the part that's smallest, the major segment would be the part that's biggest. Central angle is an angle whose vertex is the center of a circle. So here's the center of the circle, here's my angle, central angle. A sector is a region of a circle enclosed by two radii and an arc. So here's my arc, here's my radii. Radius is for one, radii is for multiple. Minor sector, just like the minor arc, is the same thing. Major sector is this part right here. A secant is a straight line that intersects a circle twice. So here's a secant, it hits it here, and it hits it here. So once and twice. A tangent, on the other line, is a line that goes right outside and barely touches the circle. Alright, so it's a straight line in the plane of a circle that touches a circle at only one point without crossing it. So it's barely touching it. Alright, the point at which the tangent touches the circle is called a point of tangency. So a point of tangency would be this point right here. The tangent line is the line that touches the circle. Concentric circles are two or more circles with different radii, but having a common center. The diagram below shows two concentric circles. So I have a circle here. Both of them have this point as its center, but the radius for this one is this. The radius for this one is twice as long, or at least we can assume. Congruent circles are ones that have equal radii. So if this radius and this radius were the same, they would be congruent circles. Eccentric circles are two or more circles. Two or more circles are said to be eccentric if they have different centers, though located within one or more of the circles. So here I have a circle, but the center for this one is C. The center for the smaller one is D. However, they're going to be different, so we have no idea about what this guy is unless I'm given more information. Alright, so eccentric means I have two circles, but the centers are not the same. And that is it.